Okay, good morning once again. So now I want us to look at what do you do when the magnitudes are unknown as well as the directions. Okay, so the previous one, the directions were known. Now this one, both the magnitude as well as the direction is unknown. Okay, so this is now the given question. Given question says two ropes support a mass with a weight of 500 newtons as shown. Calculate the tractive forces in the ropes. Okay. So the first thing you're going to do here, you're going to sketch what I would call a space diagram. A space diagram whereby you just show the forces and you get rid of the other stuff that is on the drawing. So this is your original question. Okay. And then you want to do the space diagram. So the space diagram will look like this. It's whereby, because this part just shows that it's hanging on a higher level, could be a roof or something. So your space diagram will look like this. Space diagram. (500 Newton force). Didn't I leave out the labels? Yes, force P and force T. Force P and force T. So this was force P, that is force T. Let me just double check. Yes, T is this one. So here you have force P, here you have force T, and force T makes 30 degrees and force P makes 45 degrees. Okay, clear enough. Then the next step would be to get the components of force P and force Q. But before we get the components, let's make an assumption. Because the directions are not given, we can, if we assume that they are upward like that and do our calculation with that assumption, if the answer comes as positive, it means we made the correct assumption. But if the answer comes as negative, it means they are actually facing the opposite direction to our assumptions. Okay. So force P will have a horizontal component here and a vertical component there. Horizontal component will be P cos 45 and the vertical component will be P sine 45. Force T will also have a horizontal component T cos 30 as well as a vertical component T sine 30. Okay. So, you know by now, I prefer to rewrite it so it's more clear. So down here, we can have the 500 Newton force. And then up there, we have what? T sine 30. And again, up there, we have what? P sine 45. That one. And then horizontally, we have the T cos 30 as well as the P cos 45. Okay. So we do a similar thing we did previously. Now, if we want, we can start with the horizontal components. Horizontal components are equal to 0, meaning 0 equals to T cos 30 minus P cos 45. So here we can bring P this side. P cos 45 equals to T cos 30. Then we can make P subject of the formula cos 45 divided by cos 45 both sides. So that means P is equals to, let's now divide cos 30 by cos 45. Cos 30 divided by cos 45. It gives us 1.225t. 1.225t. So we can say this is equation 1. Then if we go to the vertical components, it's going to be 0. There we have upward, we have p sine 45 plus t sine 30 minus 500. So we can bring 500 this side. And then it will say p sine 45 plus t sine 30. That can be equation 2. So the next step, we can substitute p. We can substitute this expression where we have p. So 500 equals to 1.225t. That is for p sine 45 plus t sine 30. So now we do the maths. 500 equals 2. So 1.225 times by sine 45 gives us 0.866t plus, and then sine 30 is 0.5t, that part. So t, we're going to do the maths. T is going to end up as the 500 divided by 0.866 plus 0.5. That gives us 366.032 newtons. And then we can go back to that expression to find P. So P is going to be 1.225 T, and T is 366.032. So P gives us, so this answer times 1.225. This gives us 448.389 newtons. So that is how you would find your force Q as well as your force P. So this was an example on the book. So also their B is what? 448 and their T is 366. Okay. So that's all.